Hey, welcome back, students. We're going to do sections 5.5 and 5.6, double angle and half angle identities. So the double angle identities are cosine of 2 of the angle 2a is equal to cosine squared a minus sine squared a. The cosine of, or the sine of 2a, 2 times the angle, is 2 times the sine of the original angle times the cosine of the original angle. The tangent of 2a is equal to 2 times the tangent of a, all over 1 minus the tangent squared a. The half angle identities are cosine of a over 2 equals the square root of 1 plus cosine a. So this gives us the half of the angle. 1 plus cosine a all over 2. And the sine of a over 2, okay, half of the angle, is equal to the square root of 1 minus cosine a over 2. Now these two, I'll star them and maybe even highlight them. These two, I'll wait to highlight until I show you what I want you to take from this. The cosine of a over 2 is equal to radical 1 plus cosine a over 2. Now these two half angle identities are probably the most important when it comes to calculus. So for those of you that plan on continuing into calculus, these two half angle identities are the most useful. So basically all the identities that we've covered so far, these are the ones that you're going to be using the most, because I can rewrite these in a little bit different of a form. I could write this as cosine squared a is equal to 1 plus cosine of 2a all over, maybe I'll use theta instead of a, so it's a little less confusing. Okay, over theta all over 2. And the other one would be sine of theta, sine squared of theta. Basically, I would square both sides. Sine squared theta is equal to the square root, or sorry, not the square root, 1 minus cosine of 2 theta all over 2. And these are the half angle identities, but we call them something a little bit different. We call them power reducing formulas, because what this does is it takes something that's squared and turns it into something that's linear, which is extremely useful in calculus when we don't want to have to deal with something that's squared, and we would just want to turn something that into something that's linear. Okay, so we call these power reducing formulas. Okay, because they reduce the power here, which is, again, it's extremely valuable. Okay, you can do that with the tangent function as well, but we don't use that as much. But again, they are extremely useful power reducing formulas. Okay, so I just wanted to make note of that as well. The double angle identities here, these three, these actually come from, if you took cosine of a plus b, right, and sine of a plus b, and tangent of a plus b, but you, instead of making it b, you just made it another a. Replace this with another a, and all we're doing is plugging that back into the sum to product formula from before. If we scroll up here to the sum and difference identities, okay, so notice that if I have sine a plus a, that a plus b here, that equals sine a cosine b plus cosine a sine b. However, if I were to replace that b with an a, I would just get 2 a's. And so that's how these formulas are derived, is if I take the sine of a cosine a plus cosine A sine A, well, that's just two of the same thing. Okay, and if I do that for cosine A plus A, here, that's the sine of A plus B. This is the, oh, no, this is a cosine of A plus B. This guy is going to be cosine A plus A, which is going to be cosine A times cosine A, which is cosine squared A, minus sine A, which is sine squared A. So that's cosine squared A minus sine squared A would be cosine 2A. So that's how that's derived again. And the same thing with the tangent. If I replace that B with an A, we would get 2 of the same thing on top, minus all over 1 minus the tangent squared. So again, that's how we're deriving these formulas over here for the double angle identities. Okay, we just use those sum and difference formulas. Okay, and then for the half angle identity, saying the sign of the radical is determined based on the quadrant of A over 2 of where you end up for that. So it could be a positive, could be a negative. We could really put plus or minus here if we wanted to. Okay, it just depends on what quadrant that half angle ends up in. Okay. Okay, product of some identities. This is cosine A times cosine B is equal to 1/2 cosine A plus B plus cosine A minus B. Sine of A times sine of B is equal to 1/2 cosine A minus B minus cosine A plus B. Sine A cosine B is equal to 1/2 sine A plus B plus sine A minus B. Cosine A sine B is equal to 1/2 sine A plus B minus sine A minus B. Okay, going sum to product. Okay, from this sum to product here is sine A, whoops. Let me share my screen again. This sine A plus sine B equals 2 sine over A plus B over 2 cosine A minus B over 2. Sine A minus sine B is 2 cosine A plus B over 2 sine A minus B over 2. Cosine A plus cosine B is equal to cosine over A plus B over 2 cosine times cosine A minus B over 2, and cosine minus cosine A minus cosine B is equal to -2 sine A plus B over 2 sine A minus B over 2. Okay, okay, well, let's use these formulas to find some exact values. We have the sine of 165 and the cosine of 165. Now, this is basically sine A cosine A. So what formula has sine A cosine A in it? Well, it's this one here. I'll highlight that. Okay, it's that one there. It's sine 2A is equal to 2 times sine A cosine A. Okay, so 2 sine 2, whoops, go back to my pen. So sine 2A is equal to 2 sine A cosine A. Okay, if I were to divide by 2 here, I would get 1/2 sine 2A is equal to sine A cosine A. Oh, okay. So we have the sine of 165, cosine 165 should be equal to 1/2 the sine of 2 times 165. Okay, so this is 1/2 times the sine of 2 times 165, that's 330 degrees. So what's the sine of 330? Let's go back to the unit circle and think of where is 330? Well, it's 30 degrees under the x-axis. So my reference angle is a 30-degree angle. So the x value is going to be radical 3 over 2. But what's the y value? The y value is -1/2 because it's in the fourth quadrant. Okay, and so this is -1/2 times 1/2, which is -1/4. Okay, the sine of 22.5. Well, 22.5 is half of 45. So this is the sine of 45 over 2. So we're going to use that half angle identity is equal to the square root of 1. Sine is, I believe, minus 1 minus cosine of 45 all over 2. Okay, and this is in the first quadrant. So this is quadrant 1. So I know that that's going to have to be a positive value. Okay, so this is I'm going to put a plus sign there because it's in quadrant 1. Okay. Quadrant 1 tells me that it's in sine is in the first quadrant, and signs are always positive in the first quadrant. So there's, again, this should be a plus sign. So this is equal to the square root of 1 minus cosine of 45. What's the cosine of 45? Well, it's radical 2 over 2 all over 2. Okay, so what does this become? This becomes, I'm going to break this up into a common denominator. Radical 1/2 minus radical 2 over 4. If I find a common denominator of 4 here, this is, I kind of skipped a step here. I did do radical 2 over 2 divided by 2. Okay, which is that where I got that 4 from. Okay. So if I multiply both top and bottom by 2, okay, to get the common denominator of 4, this becomes equal to radical 2 minus radical 2 all over the square root of 4. Let me make the radical a little bit bigger so it encompasses all of it. Okay, all over 4. And if I take the square root of the top and the square root of the bottom, I get the square root of 2 minus radical 2 all over 2. That would be the exact value. A little complicated with the radical inside the radical, but hey, at least it's an exact value. Okay, and what is this going to be? The sine of 22.5. And we could plug this into our calculator and see that those do come out. If I take the sine of 22.5 and I do the radical 2 minus radical 2 all over 2, those should come out with the same value. Okay, tangent of 75. Okay, if I do a half angle on this, tangent of 75. Okay, 75 is really 150 divided by 2. So the tangent of 150 over 2 is equal to, okay, if we did a half angle on this one, which one do we want to use? Maybe we will use this one. Okay, it just seems like the least complicated. It doesn't have a square root either. So if I could find the sines and cosine, I would be able to find the tangent. Okay, so this is going to be sine of 150 over 1 plus the cosine of 150. Oh, okay, so going back to that, sine of 150 over 1 plus cosine 150. Okay, so what's the sine of 150? Well, the reference angle is a 30-degree angle, and so the sine is going to be 1/2. What's 1 plus, what's the cosine of 150? Well, that's going to be a negative radical 3 over 2. Okay, now we just have to clean this up with our fractions. So this is going to become 1 over 2 all over. If I get a common denominator here, it's going to be 1 minus radical 3 all over 2. Okay, or sorry, it's not 1, it's 2. Let me go backwards. There we go. 2 minus radical 3 over 2. And why is that? Because if I multiply both top and bottom by 2 here, I get a common denominator of 2, and that's 2 minus radical 3 over 2. Again, if I multiply by the reciprocal, I can cancel out these 2's, and this becomes 1 over 2 minus radical 3. That is an exact value. However, I can do something called rationalize the denominator with our conjugate. And so if I multiply by 2 plus radical 3, 2 plus radical 3, this is something from algebra, we get 2 plus radical 3 all over This is going to be the difference of two squares. So this is going to end up being 2 squared minus radical 3 squared, which is just 4 minus 3, which is 1. So the whole bottom here becomes 1. And 2 plus radical 3 over 1, well, that's just 2 plus radical 3. So it does clean up fairly nicely. I don't have to worry about dividing by a radical. And it's no longer a fraction either. So, and again, if you did do tangent of 150 in your calculator, you would come out to 2 plus radical 3. Okay, let's look at the next one here. Okay, given sine of theta is equal to 8 over 17, and the cosine is negative, so cosines are negative here. The sine is positive, and the cosine is negative. So where does that occur? Where are cosines negative and sines positive? Yeah, that's in the second quadrant. Okay, over here in quadrant 2, we get cosines to be negative and sines to be positive. Okay, so that's in quadrant 2. We want to find the sine of 2 theta, cosine 2 theta, and tangent 2 theta using those double angle formulas. Okay, so let's do that. Okay, so in order to use the double angle formula, I want to find out what cosine of theta is. Okay, and tangent of theta, right? So yeah, I want to find out what's cosine theta and what's tangent of theta. Okay, so let's build our right triangle. Okay, so if this is theta, and we have opposite over hypotenuse, and we're in the second quadrant, then this is just, again, a Pythagorean triple. Okay, this is a 15, 8, 17 right triangle. Again, you could verify that easily by saying that this is 8 squared plus b squared is equal to 17 squared. B squared is equal to 17 squared is, what is that, 289, I think. 289 minus 64. Okay, b squared equals 225, and yes, the square root of 225 is 15. Okay, so we verify that. And why is it negative? Well, it's negative because it's in the second quadrant. Okay, keep in mind that this is in the second quadrant. Okay, so what would my cosine be? My cosine of theta would be negative 15 over 17. And what would my tangent of theta be? My tangent of theta would be negative 8, or sorry, 8 over negative 15. So 8 over negative 15. Okay. So that's the cosine theta and the tangent of theta. Okay, so now we're set to find out, well, what's sine 2 theta? Sine 2 theta is equal to 2 cosine theta sine theta. Okay, or 2 sine theta cosine theta, however you want to write it. Sorry about that. Okay, 2 cosine theta sine theta. So 2 times cosine of theta is going to be negative 15 times 17. And sine of theta here is going to be 8 times 17. If I multiply all the top together, I get 16 times negative 15, which is negative 240. And I multiply the 17 and the 17 together, I get 289. So that's the sine of 2 theta there. Okay, I don't believe that reduces either. Okay, what's the cosine of 2 theta? Well, that's the cosine squared theta minus sine squared theta. Okay, so that equals negative 15 over 17 squared minus 8 over 17 squared. Okay, so this is going to be 225 minus 64 all over a common denominator 289. And so this becomes 161 over 289. Now there is a really easy way to get tangent. Since we already have the sine and the cosine, we could just easily take and put sine over cosine, and the 289s would cancel out. So maybe I'll do that. Tangent 2 theta is just equal to sine 2 theta over cosine 2 theta, which is equal to which is equal to 240 over 289 all over 161 over 289. 289s cancel out, and I'm just left with 240 over 161. Okay, so we could do that way. If you wanted to use a formula, you could, and you should end up with the exact same thing. Okay, if you wanted to use the double angle formula, you could do that as well. Okay, let's go on to example 15 here. Flip my page. Okay, given cosine 2 theta, now they're giving us the 2 theta is equal to negative 12 over 13, and theta, the original theta is between 180 and 270, so that's third quadrant. So third quadrant, everything's negative. Remember that. Okay, so we want to find, okay, the sine of theta and the cosine of theta. Okay, so the sine of theta, half angle, right? Half of this angle is equal to the square root of 1 minus cosine 2 theta all over 2. Okay. So, so nice thing about the half angle idea is we only need the cosine to do this. We don't need the sine. Okay, because again, the cosine of theta is equal to the square root of 1 plus cosine 2 theta all over 2. So that's kind of nice. So sine of theta, okay, is equal to the square root of 1 minus, and they're telling us the cosine of 2 theta is negative 12 over 13 all over 2. So now we just have to clean this up. So this is going to be multiply both top and bottom of the 1 by 13. And I'm going to get 13 plus 12 all over 13 all over 2 square root. So that's going to be 25 over 26. Should look like this. Okay, 25 over 26. So that's the square root of 25 over the square root of 26. That's 5 over radical 26. If I multiply both top and bottom by radical 26, then we get 5 radical 26 over 26. And again, this thing is negative because it's in the third quadrant. Okay, what about the cosine here? The cosine, we're going to go 1 plus cosine 2 theta, which is negative 12 over 13 all over 2. This thing is equal to, again, we can make that 1, turn that 1 into a 13 over 13. Okay, so that becomes 1 over 13 all over 2 square root. That becomes 1 over 26 square root, which is ends up being 1 over radical 26. If I take the square root of the top and the bottom, that's 1 over radical 26 multiplied by radical 26 over radical 26, and we get radical 26 over 26. And this again is negative because it's in the third quadrant. Okay. Okay, given the cosine of s is equal to negative 3 over 7, with s being again in the third quadrant. Okay, so this is pi to 3 pi over 2. Find the cosine of s over 2. So once again, just this again is just a half angle identity. So we're finding cosine of s over 2 is equal to the square root of 1 plus cosine 2 theta all over, or sorry, it's s this time, cosine of s, because it's double 1/2 is just the variable s. 1 plus cosine s all over 2. Okay, and so this is equal to the square root of 1 plus negative 3/7 over 2. It's a 3. So this is equal to the square root of, I can make this 7 over 7. So this is 4 over 7 all over 2. So this is going to be 4 over, this is negative 4. It's basically going to be 4 over 14, which reduces to 2 over 7. Okay, that's what that reduces to, 2 over 7. So this is radical 2 over radical 7 multiplied by the, multiplied by radical 7 over radical 7 so that I can rationalize that denominator. And this becomes radical 14 over 7. Okay, and so again, where is this located? It's in the third quadrant. So since it's in the third quadrant, this is just negative. Okay, 17, simplify. Okay, well, 2 cosine squared 5x minus 1. I have to do a little bit of manipulation on this one to get it to something that I want it to look like. So this is actually going to be equal to the cosine of 2a, right? Okay, but it's not in this a form that I would recognize. So what I can do here is, instead of doing 2 times cosine squared 5x, I can do cosine squared 5x. I'm going to break this up into addition. Cosine squared 5x minus 1. And this thing here is really the negative of sine squared, right? Because if I pull out a negative, this becomes cosine squared 5x this becomes negative cosine squared 5x plus 1, which is really 1 minus cosine squared 5x, which is really from the Pythagorean identity. This is really sine squared 5x. So this is cosine squared 5x minus sine squared 5x, which is a double angle formula. So this is really going to be cosine of 10x. And that's it. Okay. So we had to kind of algebraically manipulate that. Okay. So cosine 10x. Okay, what about this guy over here? What is this thing? Well, this is just the sine, half angle sine formula. So sine of a over 2 is equal to plus or minus square root of 1 minus cosine of a all over 2, right? So this is really just going to be the sine of a, which we're calling 8 over 2. So this is just the sine of 4x. It should be 8x there. So this is the sine of 4x. Okay. Okay, let's finish up with 18 and 19 here. So write the cosine of 3x in terms of cosine x, just a cosine. So maybe I'll write this as the cosine of 3x plus x. Okay, I'm sorry, 2x. This should be 2x. 2x plus x. Okay. And so I'm going to use this formula here. Cosine of a times cosine b is equal to 1/2 times the cosine of A plus B times or plus the cosine of A minus B. Okay, so let's use that product of sum formula. Okay, because this gives me a cosine A plus B there. So this is going to be 2 cosine A cosine B. Okay. If I multiply both sides by 2, is equal to cosine A plus B plus cosine A minus B. Okay. So if I subtract cosine A minus B from both sides, cosine A minus B, I get cosine of A plus B is equal to 2 cosine A cosine B minus cosine of A minus B. Cosine of A minus B. Okay, so let's see if this helps. So this is going to be cosine of 2x plus x is equal to 2 times cosine of 2x times the cosine of x minus the cosine of 2x minus x. Okay, so that goes to just x. Okay, so this is 2 cosine 2x cosine x minus the cosine of x. Okay, so we're getting close. Okay, so we do have this double angle here. So how do we change that double angle to a single? Well, that's the cosine of 2x is cosine squared minus sine squared, I believe, right? Cosine of 2x is cosine squared minus sine squared. Yeah, cosine squared minus sine squared. Okay, so this is 2 times cosine squared x minus sine squared x times cosine x minus cosine x. Can I help? Okay, yeah, it does help. I can change this sine squared to a cosine squared. So this becomes 2 times cosine squared x minus 1 minus cosine squared x, okay, times cosine x minus cosine x. Okay, and this is equal to 2 times 2, distribute, 2 cosine squared x, because I'm combining the cosine squared x with the other cosine squared x, 2 cosine squared x minus 1 times cosine x minus cosine x. Okay, so now what we're going to get is we're going to get distribute the 2 and the cosine x, and I'll get 4 cosine squared x or cubed x minus 2 cosine x minus cosine x. Okay, and so then this becomes 4 cosine cubed x minus 3 cosine x, and that's about it. A lot of simplification there. Oops. Okay, so number 19, not as difficult as the number 18, very simple actually. We have 6 times the sine of 40 times the sine of 15. Okay, and we're going to do sum to product. So if I just took the sine of 40, sine of, or product of sum, sine of 15, that would be equal to 1/2 times the cosine of 40 minus 15 minus the cosine of 40 plus 15. Now, where am I getting that from? That's this formula here. Okay, that's, we had sine and cosine, sine and sine, right? Sine and sine. So sine and sine, that's this formula right here. Let me highlight it. Okay, that's that formula there. So we're turning the product into a product of sines into a sum of cosines. Okay, so 40 minus 15 is 25. So this sine of 40 sine of 15 is equal to 1/2 cosine of 25 minus the cosine of 55. Okay, so now what I'm going to do is I need to know, well, this isn't just the sine of 40 15, it's really 6 times that. So I'm going to plug my 6 back in, okay, by multiplying 6 on both sides. So 6 on one side and 6 on the other side. Put the 6 in there. And so this becomes 6 sine 40 sine of 15 is equal to 3 times the cosine of 25 degrees minus the cosine of 55 degrees. So distribute the 3. So 3 cosine 25 degrees minus 3 cosine 55 degrees. And that's the answer there. Okay. So that's the difference of two functions. Okay. And that's it. That's it for 5.5 and 5.6. Okay, and I will see you in the next chapter.